Good morning, everyone. Today we are excited to introduce you to HawkerGo. Our aim is to modernize the Hawker experience with AI, preserving culture while optimizing for convenience and access. My name is Veer, and today I'm here with my teammates Razan, Chin, Ishita, Hui, and Shunchi. Hawker diners today face three key issues: unpredictable crowds, long queues, and no digital experience for menus, reviews, or rewards. Our solution: HawkerGo. Think of HawkerGo as Waze meets Yelp for hawkers, where you get personalized recommendations, real time crowd tracking, smart navigation, virtual queuing, digital menus, and loyalty rewards all in one single app. Our app is structured around modular user interfaces: main UI, which acts as the central hub, user UI, which handles the login and the user profiles, then customer UI, which powers the recommendation engine, crowd reporting, and the loyalty system, the Hawker UI, which aggregates the Hawker Center data like the stall listings, the reviews, crowd levels, and the location based insights. And finally, the stall owner UI, which enables stall owners to manage menus, virtual queues, and view the analytics. Each UI is optimized for its user group, ensuring a tailored and seamless experience. Our design evolved through iterative enhancements which focused on user experience and system intelligence. Thus, our use case diagram also evolved. We began with the basic recommendation engine, then integrated real time data transport to provide context aware suggestions based on accessibility. Next, we incorporated user sourced crowd reports, enabling dynamic updates on venue conditions like wait times and congestion. Finally, to reduce friction, we added virtual queuing, loyalty rewards, and contactless ordering, features designed to streamline the user journey and drive engagement. Each feature was validated through user feedback and continuous testing, resulting in a system that is responsive, data driven, and optimized for smart dining. Now, this is our final use case diagram. I'll quickly go through the functionality so that we can move on to the demo then. This system connects customers with Singapore's Hawker Center through the mobile application. Looking at our actors, we have users as a base class, with customers and stall owners inheriting these base functionalities. We also have three external systems, which you can see down below: the Google Maps API, the LTA Data Mall API, and a recommendation ML engine. For customer, the app enables viewing hawker details, checking the crowd levels, getting directions, placing orders, tracking their order status, managing loyalty points, and finally redeeming the rewards. They can also submit review and receive personalized recommendations. Stall owners can manage their menu. They can process orders, update their status, manage queues, and view analytics about their business performance. Our external integrations are critical: Google Map, which provides the navigation, LTA Data Mall offers the transport information, and our ML system generates recommendations and predicts crowd level. Now it's time for a demo. I'll pass it on to Razan.
So Shunshi will be demoing as a stall owner and I'll be demoing as a customer. So Shunshi is going to start by showing us the stall owner registration process.
Welcome to our HawkerGo app. So firstly, we'll sign up as a store owner first. Okay, and next we'll sign in with our credentials. So in our newly created account, we don't have a stall yet, so let's go ahead and add a stall. And add our description. And here, as we can see, we have three different hawker centers to choose from. So we'll go ahead and choose the central hawker center. And I'll take the rice dishes and noodles under categories. And these are our operating hours. Okay, so now that we've created a stall, let's go ahead and add some items into our stall. So first item, And let's make it our signature dish. Okay, so now that we've added our menu items, we can actually also view the analytics of the stall. So now that we don't have any orders yet, so our total revenue is 0, ratings are 0, reviews are 0, but we do have one menu item, and these are our operating days. Not only that, we can also edit our stall details if we want to change any details. And we can also remove a stall if we want to. So now I'll pass the time on to Razan.
Right, thanks, Shinshi. Now I'll be demoing from a customer's perspective. So let's start by signing up as a customer. So by doing the exact same process as creating a stall owner account, except this time, we're just going to select customer. Now let's register. And now let's log in. So now we've entered the app. So upon entering the app, one of the things we can do is go to our dashboard and go to our preferences. From here, we can indicate the kind of food we're interested in and set our price levels. So depending on how bougie we feel. Now let's apply these filters and go back to the search hawker centers place. So as you can see, we currently have 3 hawker centers loaded. So with our ML model, we can see the nearby hawker centers, which filters it by the ones that are nearest to us. And we also have our recommendation engine. So upon pressing the recommendation engine, our machine learning server runs, taking our preferences that we just inputted as one of its factors, and also going through all the hawker centers to see what fits our preferences. So let's let the recommendation engine run for a bit. Meanwhile, let's experience some of the other UI. So we have order history. Since we haven't placed any orders yet, there's nothing to see. And it looks like our recommendation system has run. Now, let's go and search for the stall that Shunshi had just created. So let's search for the Central Hawker Center. And as we can see, currently the crowd level is around a medium. As we can scroll through, we can see all the stalls that are currently available, including the stall that Shunshi had just added. Additionally, you can see a crowd level, which shows the current crowd and also a report crowd function, which we'll get to later. Now, let's go to the Malay stall and let's see some of the statistics here. Since it's a new stall, there's currently no ratings and there's currently no orders as well. So the current order number is 0 and there's around 0 minutes of waiting time. Let's change that. Let me place an order. So now, as you can see, I've placed my order and it's currently pending. However, I may also decide to place an additional order. And I can also cancel my previous order. So now, let's go back to the Hawker Center. And also we can see that it's loaded our travel options. So this is pulled from the Google Maps API and shows us how we can navigate to the store. We can also directly press Get Directions. And this loads Google Maps and allows us to navigate to the Hawker Center. Now, I'll be passing the time back to Shunshi to see how the queue management system works from the stall owner's perspective.
Okay, so let's move on to the queue management system now. So as you can see here, we only have one order here, but just now previously Razan placed 2 orders. That's because one of the orders have been cancelled. So automatically it will be removed from this pending orders queue. So let's go ahead and prepare this order for him. So on the user side, it should reflect a ready status. And you can go ahead and complete this order. So as you can see, we've already completed this order, and now the queue status has been updated to 3.
Wow, thanks, Shunshi. Now let me show you how it looks on my end. So as you can see, we have the order that I just canceled, the order that's currently ready for pickup, and my order that is currently pending. So as Shunshi goes through her stall owner account and updates the status, I can in real time see my order status updating.
Okay. Okay, so on the stall owner side, which is not shown over here, I'll go ahead and prepare the order for Razan. Order number 3 to be specific. Okay, so now the status has been changed to ready. It should reflect on Razan's side.
Okay, so now
Okay,
you can see my order is now ready for pickup. And now, as a customer, I would go to the stall, pick it up, and then the stall owner would indicate that the order is completed. We
okay,
can also,
so oh,
we can also revisit the stall and see that the current queue number is 4. However,
stall owner will reset the queue. So I'll go ahead and reset the queue on my part. And the queue number will now reset to 1.
yes. So now let's go through some of the other functionality that's given to customers. One of them is leaving reviews. So now let's leave a 5-star review because the food here was just fantastic. Let's submit this review and go and see if our review has made it to the stall. So as you can see, my review is now placed on the stall for every other customer to see. Additionally, we can also report the crowd levels. So this helps power our machine learning model as another input to help gauge the crowd levels using the power of crowdsourcing. So it constantly refreshes even if I don't press this refresh button. And now I can add a report and submit this report. It limits my ability to report to every 30 minutes so that people aren't able to scam the system. So now we can go back and we can see that my report has actually affected the crowd level and it's now been updated to a medium. So navigating to our profile, we can see that we have a loyalty rewards section. Upon going here, we can see that I have 30 loyalty points across all hawker stalls. And for the Malay store that I just placed all 3 orders from, I currently have 30 points. The point of this is to increase social engagement and revive our hawker culture. So as a customer, I can place my order, and when I go to pick up my order, while I'm supposed to pay the hawker, I can flash my loyalty points towards the hawker. Seeing my loyalty to his stall, the hawker may decide to give me a discount or some other reward that he deems appropriate.
you can see from just now, our order has made a review. So let's view the analytics of our store. So as we can see, we made $30 in revenue from selling those orders and an average rating of 5 because there's only one review and there's only one review over here. And for menu items, we only have 1. And as usual, operating days are 7 out of 7. And we can also go ahead and log out of our profile.
With that, we conclude all of our functionality and end this demo. So now let's carry on with our presentation.
Okay, so let us go forward with our presentation. Now that we have completed our demo, I'd like to demonstrate the traceability through 2 key use cases. First from the stall owner POV and then from the customer POV. So from the stall owner POV, we have selected adding the menu item. And for the add menu item, we implemented a clean MVC architecture with proper authorization to ensure that only stall owners can add items to their menu. The backend validates all inputs and the frontend provides immediate feedback using React. Our testing included comprehensive API validation and UI responsive checks. For the order item feature, we designed an intuitive shopping cart system, like with many other apps, with atomic transactions to ensure order integrity. The implementation includes a cart-based menu display, as you could have seen in the demo, real-time cart management, and integration with a queue management system. Testing covered the entire order flow, including cart calculations and loyalty point integration. Now, these are the sequence diagrams for the same two actions. So as you can see that in the managing the stall menu and in the placing order, it's quite similar to what we showed you in the demo. Next, let us move on to the design considerations and principles. To ensure that our system is scalable and maintainable, we implemented an MVC architecture following solid design principles. Let's look at 4 key design patterns we used. The first of which is factory pattern, which dynamically creates the customer or stall owner objects during login. This supports runtime flexibility and keeps our code open for extension but closed for modification. Observer pattern powers real-time updates. When queue or order status changes, relevant users are automatically notified. Second, the singleton pattern, which ensures that only one database connection exists per user, improving performance and reducing the API load. And finally, facade pattern simplifies the controller logic, providing clean interfaces between the subsystems and the UI, which supports the SRP integration, segregation, and promotes separation of concerns. These patterns together ensure a robust, extensible backend and responsive user interface. Now, to demonstrate how easy enough it is to implement future features, since our app is designed in a way to be extendable as well as maintainable, we've uh, talked about two key features that we might think might be useful. The first of which is in-app payment system with PayNow integration. We use the facade pattern to keep the UI logic simple. The payment processing is decoupled from ordering logic via the MVC principles, and real-time payment updates are handled by the observer, so users instantly know when their payment has gone through. And thanks to loose coupling, we can easily switch to Payla or other gateways in the future. Second, predictive analytics for stall owners. We use order and queue data to train ML models and surface sale trends. This analytics service is injected via dependency inversion, keeping our system modular. The observer pattern helps update the dashboard in real time as new data about sales and queue trends flow in. Now for the white and black box testing, I'd like to pass it on to Razan.
Thanks, Peter. So, as you saw in our demo, we use emulators and Expo to use black box testing throughout our development phase. So this allowed us to see the external behaviors of our app. However, we also extensively implemented white box testing in our CI/CD pipeline. We originally wrote tests based on our software requirement specifications from previous labs. Through our extensive code coverage, we tested every single endpoint within a function, allowing us to debug more effectively. This also made the whole process of the software development lifecycle more efficient because we would catch bugs before they would become an issue later on. This also aided in our verification of requirements from the software requirement specifications. Moving on to the next slide, let's talk a little bit about how exactly our tests work. So as you can see, we've split the tests into front-end and back-end tests. So here are some of the files that we have. We used the Jest framework, which was designed for React Native apps, and we implemented them very extensively throughout our project. So throughout the development of the app, due to evolving requirements, the passing of tests also evolved. So 2 weeks ago, when our app was still in an infant stage, we managed to pass all the tests with the software requirement specifications as was given in Lab 1 and Lab 3. However, as we kept building and developing the app, we came up with new features and new functionality. So as of right now, our backend tests are at a state where we fail 103 tests, but we also pass 165 tests. And the front end tests are at a state where we fail 3 tests, but pass 8 tests. Moving to the last slide, this is one of our tests that we wrote. So as you can see, it's a very basic framework where we simply expect the status code, body, and the user email to have certain values based on what we input towards the route. With that, we conclude our presentation, and we'd like to thank you for your attention. We hope you're inspired by HawkerGo and believe in our app.